going to review what we did the other day. Well, stupid boy. I'm going to review this real quick. I'm going to go kind of fast because it is a review. And again, I shall send you a recording of this. Before I forget, we will not be taking attendance. This is an online class, so that's really no way to do it. But there won't be any attendance. The only thing I can do is use the if you do the quizzes on time. Again, and one other thing, I will not fail anyone unless you roll over and play dead and not do anything. But the worst I'll do is give you an IP. It means in progress, and you have to do this stupid class all over again. I do get online at about 6:30, more or less. And remember this Sunday, the time changes, so don't forget that. And quiz number 2 is up and ready to go. Okay. We're going to review what we did last time. These are very important words. Terms are one number, like 5. 4x looks like there's 2 numbers there, but they're treated as 1. And 2xyz, that's also a term. Expressions are greater than one number. 3a plus 2b, if it has a plus or a minus in between them, then it's an expression. There's actually, 3 terms in here. PEMDAS, probably the most used thing we do in mathematics is this order of operations. The first thing you do, for instance, if you have 3 plus 2 times 4, we have addition here and we have multiplication here. Do we have parentheses? No. You have an exponent? Yes. Now, multiplication, division, they're like twins. You do whichever one comes first from left to right. So we're going to do multiplication first. So it's 3 plus 8, which is 11. Everybody got this? This is not going away. You're going to see this forever. The P is parenthesis. E is an exponent. We'll go more into exponents. Maybe not next week, but probably the following week. The M and the D, again, are like twins. You do it's multiplication, division, whichever comes first from left to right. And the same thing with addition, subtraction. Now, like terms, they have the same variable. Now, variables are letters, A, B, C, D, X, Y, Z. The same variable, excuse me, and the same exponent. So if you have 3a plus 4a, now the exponent on these are 1, we just don't write it. They have the same variable and the same exponent, so we can combine these. Now, if you get something longer, they really don't get any more difficult than this, they just get longer. So if you have 5a plus 2b plus 3a plus 4, I have to underline them because I'm stupid. So I underline the like terms, and 2b and 4b, those are like terms. So 5a and 3a are 8. I'm sorry, 5a and 3a are 8a, and 2b and 4b are 6b. So there's our answer. Everybody got that? This is not going away either. Distributive property of multiplication. This is the only one I'm going to irritate you with. There's 4 properties. This is the only one that's important. What in the world did I do? This is supposed to be 6. You multiply 3 times every term inside of the parenthesis. 3 times 2c is 6c. I'm sorry, my handwriting's bad enough as it is. 6c. 3 times 2c is 6c. 3 times 5e is a plus in there. Is, what is that, 15? 15e. Okay. This is not going away either. Everybody okay with this? Okay. Solving equations. Very simple. This is kind of the basis for everything we do in algebra, or solving equations. So we have g plus 2 equals 5. We want g over here by itself. We want to solve this equation for g. So whatever you have here, you do the opposite. If it says plus 2b, we subtract 2b. Whatever you do to one side of the equation, you have to do to the other side. They're like equations like seesaws. This side is equal to that side. So if you subtract 2 from each side, you get what in the world? Yeah. Minus 2 is 0. It's gone. It's eliminated. And that's what we want. We bring the g down, and 5 minus 2 is 3. To check it, you put the 3 back in for here for g. G and 3 are the same. They're exactly equal. So you put 3 in for g. 3 plus 2 is 5, so we are correct. Same thing here. The only difference is this one has subtraction. So what's the opposite of subtract? Add. So we're going to add 6 to this side. Whatever you do to one side, you have to do to the other. Okay, so this is gone. And 2 plus is 8. Plug it back in. 8 minus 6 is 2, so we are correct. Everybody okay with this? This is not going away. Okay. Okay. Okay, before I forget here, this is something that seems to give everybody fits. If you have a positive number times a positive number, what is that going to equal? A positive number. So like 3, a positive 3 times a positive 2 is positive 6. Okay. A negative times a negative is also a positive. So if you have negative 2 times negative 3, negative times a negative is a positive 6. Now, if one of the numbers is negative and the other number is positive, the answer is negative. So if you have negative 2 times a positive 3 is a negative 6. Now, these rules are the same for division. D-I-S-I-O-N. Same for division. So if you have a negative divided by a negative is also a positive. Okay. And if you forget, your brain goes numb, whatever, put it in your calculator. For instance, first you turn it on. So if we have a negative 18 divided by a negative, please think, 6. Now again, when you do this, look up here and make sure you entered it incorrectly. And the answer is a positive 3. And if you have negative 25 divided by 5, okay, a negative divided by a positive is going to be a negative 5, okay? If you forget, put it in the calculator, but again, please don't tell Dr. Burke you on me. I'm in enough trouble as it is. Okay, now, again, we're solving equations, OLVI. Solving with multiplication and division. Okay, so if you have 4h equals, come on, boy, think, 20. 4h means 4 times h. We just don't write it. But that's what that means. Now, how do we undo multiplication? Just do the exact opposite. This is to multiply, we divide. Divide by 4. Remember, the fraction bar also means divided by. And whatever you do one side, you have to do the other. Divide by 4. 4 divided by 4 is 1. 1h, or just h, equals 5. If you're not sure, plug it back in. 4 times 5 is 20, so we are correct. Now, if you have negative 6k equals negative 30. Now, what are we going to do here? Divide by negative 6, because a negative divided by a negative is a positive. Positive 1k, or just k. Whatever you do to one side, you have to do the other. Equals a negative divided by a negative is a positive 5. Plug it back in. Negative 6 times 5 is negative 30, so we are correct. Okay. Negative 8n equals 48. If you can't read my writing, please be sure and tell me. You're not going to hurt my feelings. I know how bad it is. I used to tell people that it's a product of too much education, but nobody ever believes that. Divided by negative 8, divided by negative 8. Negative 8 divided by negative 8 is a positive 1, and or just n. Now, positive divided by, this is fun stuff, huh? Yeah. Is a negative. Was that 6? Something like that. Everybody okay with this? Okay. Okay, now two-step. SOLVIST. Solving two-step equations. For instance, if we have 5p plus 2, okay, now we have multiplication here, it's an m, and we have addition equals 17. Now remember, when we're solving equations, we do PEMDAS backwards. First, we get rid of addition, subtraction. Then we get rid of multiplication, division. Then the exponent, then parenthesis. Okay, so the first thing we get rid of is addition, subtraction. So we're going to get rid of, excuse me, subtract 2 from each side. Okay, this is what we're doing here is we're combining the first set of equations that we did in the second part. But it's all the exact same thing. They really don't get any more difficult, they just get longer. Okay, so that's gone. So we have 5p equals 17 minus 2 is 15, I think. And then we divide by 5, divide by 5. P is 3. You plug it back in, 5 times 3. Now we do PEMDAS the correct way because we're evaluating. I'm sorry to use these words, but they're this is what you're going to see on the final exam and forever also. 5 times 6, 15, plus 2 is 17. So we're correct. And three R plus 2, that's a plus, is 14. Basically the same stupid problem. First we get rid of addition, subtraction. This is multiplication. This is addition. We subtract 2 from each side. That's gone. The only thing that's left is a 3R equals, what is it, 12? Divide by 3, divide by 3. R is 4. I took a class at Prairie View, quite a few years ago. It was a calculus class, and the teacher was a clone of Halle Berry. I mean, this woman was gorgeous. But the poor thing, and smart, God, she was smart. But the poor thing could not add and subtract and multiply and divide. But she looked just like Halle Berry. Oh boy, she was pretty. Okay. What about this? Get this if you're so smart. 8t minus 4. Okay. Again, we have multiplication here, subtraction here. So we're just going to do the opposite of whatever it says. We're going to add 4 to each side. Eight t is 16. Now we divide by 8. Divide by 8. T is 2. Now plug 2 back into the original equation and do PEMDAS the right way. 8 times 2 is 16, minus 4 is 12, so we are correct. Is everybody okay? Am I going too fast? Please be sure and tell me if I'm going too fast. Say, slow down, boy. Mm-hmm. 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 Okay. Again, same problem. Multiplication here, subtraction here. So we're going to get rid of the addition, subtraction first. So we're going to add 6 to this side. Whatever you do to one side, you have to do to the other. We're left with 5u equals 15. Divide by 5, divide by 5. U is 3. Mm-hmm. Mm-hmm. 2v minus 9 equals negative 19. Same thing. We're going to add 9 to each side. When we're adding and subtracting, if the signs are different, we subtract, take the sign of the larger number. Okay, negative 19 plus 9 is a negative 10. Divide by 2, divide by 2. V equals negative 5. Mhm. Okay. Okay. Negative 4W minus 7 equals 5. This is about as difficult as these get, and it's really not all that difficult. Just has godless negative numbers in them. Mhm. Add 7 to each side, get negative 4W. Well, the older I get, the worse my handwriting gets. It was already terrible to begin with. Equals, what is it, 12? Something like that. Okay. Divide by negative 4, divide by negative 4. W equals, now we have a positive divided by a negative is a negative 3. Am I going too fast? Is everybody okay? Mhm. Okay. Okay. Where are we? Negative 6y minus 5 equals negative 29. Now again, we're going to get rid of the addition subtraction. So we're going to add 5 to each side. Negative 6y equals negative 24. Okay, signs are different. So we subtract, take the sign of the larger number. Actually, that's smaller, but you see what I'm saying. Divide by negative 6, divide by negative 6. Y is negative divided by a negative is a positive. Was that 4? And you can plug it back in. Negative 6 times 4 is negative 24. Negative 24 minus 5 is negative 29, so we are correct. Mhm. Okay. Now, what if we have this? Get this if you're so smart. 4b plus 2 equals 3b plus 5. Now, what we want to do is we want to get the variables on one side and the constants or the numbers on the other side. Now, the thing you want to do here, excuse me, the thing you want to do here is move the variables first. You don't have to do that if you end up with some godless negative number. So move the small one first. Move this over here. How do we get rid of a 3b? We subtract 3b because any number minus itself is 0. Okay, draw a nice pretty line. 4b minus 3b is 1b or just b plus 2. Be sure and bring that down. equals, that's gone, 5. Now we subtract 2 from each side. B is 3. Excuse me. I'm afraid I might have the COVID. Okay, put 3 back in wherever there's a B. So 4 times 3 is 12, plus 2 is 14. So you got 14 over here on this side. And 9 plus 5 is 14 on that side. 14 equals 14, so we are correct. Okay. Get this if you're so smart. 5C minus 4 equals 3C minus 10. Now again, move the variables first. So we subtract 3C from this side. Excuse me. So 5C minus 3C is 2C. And off of 0, we bring down the negative 4 equals negative 10. Now we add 4 to each side. Negative 6, 2C, bonehead, 2C equals negative 6. Divide by 2, divide by 2, C is negative 3. Negative divided by a positive is a negative. Okay? Anybody want another one of those? Everybody asleep? Y'all scare me when I don't hear anything. It's like you're doing something bad.
We're focusing.
Huh? I heard somebody talk, but I didn't hear.
I said we're focusing.
You're focusing. Okay. Mr. Hippolyte, I think you're going to be a troublemaker too. Ms. Gill, she's a bully. Matona. I don't know what that means, but it sounded Spanish. Okay, get if you're so smart. Now, like I said, these problems, they really don't get any more difficult. They just get longer. Okay. Be sure and tell me if you can see my paper okay. Because the picture I have of it here on my computer is real small. 6x plus 5 plus 7x plus 3 equals 12x plus 4. I don't know about you, but I see a problem like this and my brain collapses. No, hell, I can't do this. This is way too hard. Yeah, you can. What? Just ask yourself, say, self, what can I do here? Well, you can combine like terms, right? 6x's and 7x's, 5 and 3, and we don't have any like terms over here. So we have 6x and 7x is 13x, 5 and 3 is 8, equals 12x plus 4. Now we have the same stupid problem we had before. Move the variables first. Now, if you want to move the variables and the constants at the same time, you can do this, but I would wait until you get a little bit more comfortable with doing this. 12x minus 12x. Be sure and line them up like terms. 13x minus 12x is just 1x or just x plus 8 equals 4. Subtract 8, subtract 8. X is -4. Everybody okay with that? It's just a real long problem. It's not difficult at all. But when you first look at it, I think, oh crap, I can't do this. That's way, I'm too stupid. I can't do this. Okay. Everybody got this? I'm gonna throw it away. I'm not kidding. I'm gonna throw it away. Okay. Now this is about as difficult as these problems get, and it's really not all that difficult. For open, 7x minus 1 closed, plus 3 open, 2 minus 5x, 2 minus 5x, minus 4 open, 3x plus 5 closed, equals -6. Again, you look at this misery here and you think, oh man, that boy has lost his mind. I can't do this. Yes, you can. What's the first thing we say, self, what can I do here? Well, I can do distributive property, right? We're going to distribute the 4 over everything inside here. We get 28x minus 4. Remember, multiply 4 times everything inside the parentheses. Same thing here. Plus 6 minus 15x. Same thing here. Minus 12x minus 20. -4 times a positive 5 is -20 equals -6. Now what can we do? Combine like terms. Am I right or am I right? I'm right. I'm always right. Ms. Watts is sitting and rolling her eyes. I can hear it from here. X is there. X is there. X is there. -4, positive 6, -20. Okay. 28x, excuse me, minus 15x is 13x. 13x minus 12x is just 1x or just x. Everybody with me here? Look, we can do that on the calculator too. Make sure I'm not a bigger bonehead than I think. We got 28 minus 15 minus 12. 12 is 1, positive 1. Now we have 4. I'm sorry, -4 plus 6 is 2. This is just 6 minus 4. It's just written backwards. So we have 2 minus 20 is -18 equals -6. I think that's right. Now, this is the same problem that we had at the very beginning. Add 18 to each side. X equals 18 minus 6, or you can say -6 plus 18 is 12. And when you first look at this, you think, oh man, that boy has lost his mind. No, these are real simple. They're just real long is all. You got distributed property, distributed property, distributed property, combine like terms, blah, blah, blah. What could be more fun? Okay. Okay, this is actually the same problem, just shorter. 4 open, 4 minus 3x. equals 32 minus 8 x plus 2. Okay, again, what can you do here? We do distributive property here. Multiply 4 times everything inside. 16 minus a positive times a negative is a negative. 12x equals 32. Now we distribute the negative 8 over everything inside here. Negative 8x minus, 16, negative 8 times everything inside. Negative 8 times 2 is a negative 16. Now, move the variables first. What we really want to do here is move the 12x over here. That's actually the smaller number. Negative 12 is smaller than negative 8. But you can do it the other way too. Add 12x to each side. $16 equals, let's combine, well, no, let's not. 32 plus 4x minus 16. Now we have like terms here. Right. 32 minus 16 is at 16. Subtract 16 from each side. Get 4x equals 0. Divide by 4, divide by 4. X is 0. Can we have 0 as an answer? You betcha. Remember, what this means is, how many 4s are there? How many 4s are there in 0? There are none. But now if you had 4 over 0, this is asking how many zeros are there in 4? That doesn't make any sense. So this is the null. So this is undefined. But this is 0. If you forget, if the 0 is over, the answer is 0. If the 0 is under, it is undefined. Okay, if the 0, but again, if you forget, brain goes numb, first turn it on. 0 divided by any number, like 5, is 0. But now if you have if it's the other way around, 5 divided by 0, you're going to get an error message. And you're going to have to snap to the fact, what in the world have I done? Okay, now, division. And again, that's about the most difficult problems like this. They're not really difficult, they're just long. Now, what if we have this? What does this mean? The fraction bar means divided by. So how do we undo division? Multiplication. We're going to multiply by 3. Whatever you do one side, you have to do the other. So A is 15. Put 15 in here. 15 divided by 3 is 5, so we're correct. B divided by 8 is 10. How do we undo division? Multiply by 8. Whatever you do to one side, you have to do the other. B is 80. Mm-hmm. C divided by 6, I'm sorry, C divided by negative 6 is 8. So we're going to multiply by negative 6. Because a negative divided by a negative is a positive, and that's what we want. And a positive divided by a negative is a negative 48. Oh, that's good water. Okay. Okay. Oh, here, I forgot a problem. Sorry, I'll do better. No, I'm not going to do any better. 2x plus 8. Equals 4 open 3x. This is kind of a trick problem. Okay, first of all, what can we do here? We can do distributive property. Okay, we're going to distribute the 6 over every term inside. Get 12x plus 48 equals, same thing here. I'm not stupid. 12x minus positive times a negative is a negative 24. And move the variables first. Negative 12x. Negative 12x. What do we get here? 48. That's gone. That's gone. Is negative 24. Is this correct? No. So our answer here is no solution. When we go to graphing problems, we'll probably do that next week or week after. We'll talk about no solutions, one solution, or whatever. Okay, so 48 does not equal negative 24. Does not equal. This is. Oh, and before I forget, do not use this. Not equal 0 means something else. This means no solution, the null set, blah, blah, blah. So don't you, back in the day when computers were so, computer printers were so poor, they had to distinguish between the letter O and the number 0. And that's how they did it. But we don't do it anymore. Okay. Mm-hmm. Okay. Word problems. What fun are word problems? A piece of rope, R-O-P-E. This is going to be on your final exam. Won't be this exact problem, but it'll be very similar to it. The longer piece is twice as long as the first piece. The length of the rope is 12 meters. How long is each piece? EACH. Well, I'm sorry, but I have to draw pictures because I'm stupid. Here's a piece of rope, right? Right. Now, the length of the rope, the whole thing, is 12 meters. Okay, it's cut into two pieces. This is piece number one, and this is the second piece. The longer piece, this one, the second one, is twice as long as the first one. So what's the length of the first one? X, we don't know. So what's the length of the second one? Twice. That's what my ex-wife would say, twice. Twice as long. So 2x. Everybody with me here? Okay, so how are we going to find out what each one of these is? We're going to make an equation. This piece plus this piece plus 2x is going to equal 12, right? Okay, you just add the two pieces together and they're going to add up to the overall length. Now we have like terms here. So 3x equals, stupid boy, 2x, 3x, okay, x plus 2x is 3x, equals 12, divide by 3, x is 4. Is this our answer? No. Remember in the second grade how they told us underline the important stuff? I can remember thinking, oh, I'm not doing that. I know what it's at. Well, our second grade teacher, she was right. We want to know how long is each piece. Okay, the first one is X. So the first one is 4 meters. The second piece is 2 times as much, so 2 times 4, which is 8 meters. Now, what is our acid test here? How do we make sure we're correct? 4 plus 8 is 12. Okay, and these are not real difficult. The secret to doing word problems is go slow. Write it, draw a picture if you have to, and write it out in numbers. Oh, that's good water. Everybody okay with this? Not super duper whiz bang important, but you are going to be irritated with this. I'm probably going to give you one on your first test, and it'll be on the final exam also. Okay. 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 A 2x4 That's a hunk of lumber. Cup is cut into 3 pieces. E pieces. The second piece, E-C-E, that's P-I-E-C-E, there's an E there, sorry, is twice as long L-O-N-G. As the first. The third piece P-I-E-C. Am I writing too small? Can y'all see this okay? Mr. Hippolyte, can you see that?
I see it.
Okay. Third piece is 4 inches more than 3 times the first. How long is each piece? Okay. Again, I'm sorry, but I have to draw pictures. There's your 2x4. Oh, wait. The overall length L-E-N-T-H is 40 inches. Okay, so this is 40 inches. The overall length is cut into 3 pieces. Here, here, and here. First, second, third. Okay. The second piece, this one, is twice as long as the first piece. So how long is the first piece? This is the thing that always stumped me, was what's the first piece? Well, it really doesn't tell us. But it's X. This one is relative to this. It's twice the length of the first. So it's 2X. Now, these are the ones that always got me. This one, the third piece is 4 more than 3 times the first. Take these real slow, take them 1 piece at a time. 4 more. How do we write 4 more in math? Plus 4, right? And how do we write 3 times the first? Okay, 3 times the first. Now, when we add all these together, they're going to come up to 40. So we're going to have X plus 2X plus 4 plus 3X. Now, you could put 3X plus 4. It doesn't make any difference. It's just like 3 plus 2 or 2 plus 3. And when you add all these together, it comes up to 40. Now we're going to combine like terms. Here, 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 and we have the constant there. So 1X and 2, that's 3X, and 3X is 6X. Does everybody see how we got that? Plus 4 equals 40. Now we have a really simple algebra problem. Subtract 4 from each side. 6x equals 36. Is that right? Because my brain went numb. I think that's right. Divide everything by 6. X is 6. Is that our answer? No. Remember, how long is each piece? So this one's 6 inches. This one's 2 times 6, or 12 inches. And this is 4 more than 3 times. So 3 times 6 is 18, plus 4 is 22. Now what's our acid test here? Add all these up. 6 and 12 is 18. 18 and 22 is 40. That's so we are correct. 6 plus 12 plus 22 is 40. So we are correct. Right? Right. Okay, I'm going to put one more thing in your ear before we go. And I'll go over this again on Thursday. Remember, if you want to, excuse me, if you want to come to the class on Thursday, being that it's Halloween, I thought we would move the time to 10 o'clock in the morning. But again, I'll make a recording. Unless Ms. Gill forgets to tell me to push the record button. So 10 o'clock Thursday. Don't forget the time changes this Sunday also. Okay. And we'll go over this again Thursday. There's a little square here in the, oops, sorry. The little square here in the middle means that it is 90 degrees. This is 180 degrees. Now, two angles that add up to 90 degrees are called complementary. C-O-M-P-L-E-M-E-N-T. C-O-M-P-L-E. C-O-M-P-L-I is, oh, you're so pretty. That's a compliment. But C-O-M-P-L-E means two angles that are add up to 90 degrees. So if we had this angle, and this angle, these two angles are complementary. If 50 degrees, this one would have to be 40 degrees. These are complementary. Tell you one way you can remember this is complementary starts with the letter C. Now, what number can you make out of a C? 9. Right? Supplementary are two angles that add up to 180. So if you have a straight line, this one is 100 degrees, then this one would be 80 degrees. These are supplementary. U-P-P-L-E-M-E-N-T-A-R, I think. Supplementary. Supplementary angles add up to 180. Complementary add up to 90. And we'll go over this more on Thursday. If y'all had enough, your head's throbbing. Okay, if you want me to go over anything, I'll be more than happy to stay. I have nothing to do but go home and cry myself to sleep. I hope y'all appreciate it. I missed my early evening nap to be with y'all. Okay, If you have any questions, like I said, I'll hang for a few minutes until everybody's gone. See you Thursday. Bye-bye. Bye, Bonds.